It's another week, it's another devlog. Today we are talking about artificial intelligence, something that I wish I could implement in my own brain because my natural intelligence doesn't quite cut it most of the time. Anyway, it sounds like a scary topic, I am aware, but we're going to go through this. It's not all that complicated, and I'll just show you what the things are that I made, even though they are relatively simple. And some of them definitely need a little bit more polishing, a little bit more work before they're finished. I've got 5 of them here. We're just going to walk through this little strip of enemy danger here, and you'll see them all working in their somewhat intended way, one by one. So the first one here, you could see just before, had a collision sphere. And the moment we enter that collision sphere, it'll start chasing us. And it won't stop chasing us until we either exit the nav mesh that it's in, or we get far enough away from it, at which point, in either case, we will have it return to its spawn point. And of course, it's got a stomping to kill it mechanic. We'll talk about these shooting enemies a little later at the end of the whole thing, because those are the most, well, not most complicated, but they require the most explanation, I would say. Here we have 2 enemies that you might think are the same. And you would be correct to a certain extent because they're the same model, but they have very much different behavior. I'm going to kill them both, and then I'm going to explain it to you. Because one of them, and I'll just exit out here real quick, one of them started all the way over here, or one of these anyway, and what they do is they pick a random location within the nav mesh that they can navigate to, they move there, they wait for a little while, about a second or so, and then they choose a new location to move to and rinse and repeat until they die. This one over here, though, is a little more complex than that. And I say a little because it really is only a little. What this one does is it has these little target locations, and it just moves from these locations to one of the other locations. It can either do that randomly or sequentially. We'll get into that a little bit more once I start explaining the technical side to things. So that's that. Let's get back into the game itself. Immediately kill these 2 because these shooting enemies are actually really annoying to deal with when I'm trying to explain shit. Then we have this one, and this one is definitely the most complicated, which by no means says that it's actually a very complicated AI, which at the moment we'll check its behavior tree out, you'll see it's actually really simple because it's barely like a behavior tree in the way that it doesn't really make choices. It just waits for a condition to be met and then does some AI related shit. And that condition that needs to be met is I need to be inside these blue particles. So when I am inside, you will see it will start tracking my location, and after a little while it will sometimes bug the fuck out. It will start tracking my location, and after a little while it will run towards where I am and then run back towards the starting location. The issue being is that it sometimes glitches out, and I think I know why that is, because it doesn't check whether or not the overlapping, it needs to check whether or not the end overlapping is the player character and not just any actor, because now these guys are kind of fucking up my AI. So now it should work a lot better than it did before. So the moment I enter this, it will start tracking me, it'll run towards the location I was at, then go back to the spawner location, and then it will just rinse and repeat until I move out of its range, at which point it will just kind of like stand around. The big difference between these 2 is that when this one starts chasing you, the collision around it will move with it. So it will, as long as it's got a nav mesh, it will keep running after you. This one will only ever operate within the range that you set it. This collision sphere will not move. This collision sphere will stay where it is. That's the only place it's ever going to be dangerous inside. Then we have these little fuckers, which I've already explained plenty about. I think at this point, they just pick a random location and move towards that, which only leaves us with the very last one, and that's these shooting enemies. So let me get close to one here, because I wanna, that's the wrong button. That's also the wrong button. I want to try seeing if I can get your perception showing. There we go. Okay, so we have this perception here, which it's a very long range sight he has. I'm going to probably decrease that by a fair bit. But you can see as long as I'm outside of his range of vision, he just walks around randomly. Uses the exact same code as the other enemies that walk around randomly. But the moment it sees me, which is different from being inside of its range, because it actually needs to face me. If you look at it from a top-down perspective, you will see that these two green lines going to the side show its peripheral vision, right? So it will always look towards you once it's spotted you. I probably should program it in a way to, like, when you jump over it won't see you anymore or something like that. I'll look into that a little later, because at the moment it uses the same tracking code as the other enemy that looks at you once you get inside of its range. But this uses the built-in perception mechanics from Unreal's AI controllers. So that's how this works, and of course you can still just kill it. It's relatively simple, really. You just need to have a good look at it. Let's look at the actual functionality of these one at a time, going from left to right. So the first one we have here is the one that keeps chasing you until you exit its range, or of course the nav mash. This looks complicated, but once we discard this, which is a lot more scary than it looks, a lot more scary than it actually is. What happens here is when we have the player specifically, and that's what this node here does. It's a little like macro function which just says input other actor, compare it to get player character. If that's true, move on in the node tree. If that's false, just stop. Just, you don't need to do anything else. So if that's true, it sets in player radius a variable to true. Here the same thing with and overlap. So when you exit the collision sphere, it does the same check to check whether or not the player exited. That's the one thing I added to that other AI just a moment ago. I had forgotten to do that. And it sets player and radius to be false. Now, in the event tick, which is just something that runs every game tick, you can think of it as every frame. That's not exactly correct, but let's, for the simplicity, every frame. It checks whether or not player is in radius. If it's false, it moves back to its starting location, which gets set at the very start when the game loads up, by just getting the actor location and store it in a variable. That being said, if the player is in the radius, it performs a line tracer from the player character's world location downwards. That's what this is. It has a start location of the player character. It has the end location of the player character, X, Y, exactly the same. And then the Z is minus, you can't really see the minus here, but if I zoom in a bit, you can maybe. Minus 1200. So it just goes down 1200 units, and it does a line tracer. The out hit location is where the AI moves towards. Why I do that is because if you don't do that and you just make it move towards the world location, when you jump, it loses the ability to track you because you're no longer inside of the nav mesh. This way, when I jump, it still is tracking my player location, but it just doesn't take jumping height into account. So it will still keep tracking you when you're jumping around. And since this is a platformer and I expect and want my players to be jumping a lot, and I want the jumping to be satisfying, but that's a whole other thing, I need the enemies to be able to track me when I'm jumping. So that's what this line tracer does. Again, it's a very, very big node, but that's only because this has been split into so many different pins, because I only needed a hit location out of it. If it's just one pin, it looks a lot less intimidating. And that really is all there is to it. Everything else here, this is just like the checkpoint system, and this is just the hitbox system that every single enemy has. So it's really that easy. Then we get to, we'll save this one for, actually no, let's do it right now. Let's do the shooting one right now. So the shooting one doesn't actually have much code specifically to it. What it does have is its movement radius and time between movements, which are variables that you can set in here. It's got a movement radius of 1500. That means that when it's walking around randomly, it does that within a 1500 unit radius of where it currently is at. And the wait time is just how long it waits between reaching the destination and moving to the next one. And then we have the maximum walk speed and acceleration and stuff like that for just like general movement related purposes. It passes those variables that you put in to the blackboard that the behavior tree uses for the AI. Then again, this is just simply the checkpoint system. This is the hitbox system. And what we have here is a shoot player function, which is not very orderly at all. And that literally just spawns a projectile actor, which is rotated towards the player. So it just goes towards the player. It's really that easy, because when we get the, hold on, where shooting enemy, there we go. That's the AI controller. It's not what I wanted to have. Where is it? Where is it? Shooting enemy. There we go. If we go to the actual projectile blueprint here, you will see that it's very easy. It just has a projectile movement, meaning that when it gets spawned, its initial speed is 2500. Its maximum speed is 10,000. That's just some tweaking around, which I'm going to have to do a lot more tweaking around to get it right. But for the time being, this will work. Its projectile gravity is a 0.1. So it has a little bit of gravity, but not too much. I'm honestly considering making this even lower, because it does reach the floor very, very quickly. Also, I need to add in a thing where after like 2 seconds of existing in the world, it just destroys itself. Because the moment when a projectile misses, it just keeps moving on forever. Anyway, the only thing that this projectile has is when it overlaps with the player character, it casts to the player character, deals 1 HP of damage, and then destroys itself, that being the projectile. So, relatively simple, needs a lot more tweaking. I made this in like an hour and a half. Last night before, something like that. Then, actually, no, we have to look at your behavior tree as well, don't we? It's really simple. When we can see the player, which is set in the AI controller, yeah. So when the perception, which is a component in the AI controller, is updated to see specifically the player actor, we just say that last known player location is set to wherever it is. That is what I use for the rotation of where I'm shooting at, or where the AI is shooting at, rather. And then I also set the can see player. Both of them get passed to the blackboard. I don't think I need this one on the blackboard now that I think about it. I just did that because I thought I would, but I don't think I ended up using it on the blackboard. Anyway, so when the can see player is set to true, it starts looking at the player, which is the same function, again, that the chase AI within the range uses. And then I'll just show you what that is like. It stops any movement in case it was moving around. Then it adds in a delay here for about 1.5 to 3 seconds before it finishes executing. That is mostly because that way I don't have to add like a wait node, and it will keep rotating during that waiting time and stuff like that. And during that, we have an event receive tick. So as long as this is receiving inputs, it will do this every tick, and that's just setting the actor rotation to face the player character. And then it does the task shoot, which literally just casts to the shooting enemy and calls for the shooting player event to be triggered. If it's not in seeing range, we just move to a random location, and then we have a custom wait time, which is driven by, again, this number over here, the 1. I can set that to 10, and it will wait for 10 seconds, more or less. It's a little bit more complicated. I have a random float and range setup here, which all this really does is take the wait time and add between 1 and 25% of that wait time randomly on top of it, so it's a little less like mechanical and it feels a little bit more natural. How it's slightly random, how long it waits, also makes it a little less predictable from a gameplay perspective, right? So that's the shooting enemy. I've been talking for 15 minutes, but we're most the way done. I think the next one we should talk about is this one. And this one is pretty self-explanatory, really. Let's start here. Again, this is just the usual, what you would expect it to be. It's the hitbox system. And then we have a couple of things going on here, right? So let's actually put these in separate comment boxes so they're easier to distinguish. We have a begin play. And in begin play, what we do is we get the array of location points, which we set in the level editor by just like simply, let's copy this one over and put one over here. We can just add an array element. We just, wait, where did I put it? I don't know. In theory, we should be able to put any actor into that, actually. So even moving actors, even other enemies we can put into that. I'm not going to do that for now because I don't want to. But in theory, moving actors around, you should also be able to still use this because it takes the location of the actor in the world. So if that location changes, it will just move to that location instead. So it gets the index 0 from that array and sets current goal, which is a variable that's very important to how this works, to that first index. And that's just because otherwise current goal doesn't have a value and it needs a value right from the start of the game. So we then pass that over to the blackboard for the AI, as well as whether or not I've set it to random order. If it's not in random order, it will go through this whole array sequentially from 0 to 1, 2, 3, 4, 5, etc. Once it reaches the end, it will loop back around to 0. If I have random order set, it will just move to a random location or a random entry in the array, and then it will just pick another random entry in that array. We'll go into how that does that right now. So firstly, the pick random goal. We set the current goal because that's a variable that we use to determine where we're moving towards in this way over here. So we get the array, and with this last index and a random integer in range, we pick a random integer between 0 and the last index of the array. So that's very scalable. If the array has 3, it picks 0, 1, 2, or 3. If the array somehow has like 150 entries, it picks any number between 0 and 150. That's to make sure that it doesn't like go over the amount of entries that I have in the array and just absolutely shits itself, right? And that just, once that's set, it passes that on to the blackboard, so the blackboard knows what to do with that. Relatively simple, and this looks a lot more complicated because using a lot more nodes, it really isn't that complicated because pick's next goal is the exact same thing, but instead of taking the entry from the array or the index just randomly, it just looks at what is my current entry and adds 1 to that, which is what this is. Current index plus plus, which is +1, and then it real quick checks whether or not that makes it go over the last index of the array, again, to make sure that it doesn't overflow in any weird way. If it is higher than the max, so if we've got entries 0 to 5 and this little action over here makes it go to 6, this branch pops in and says, wait a second, we can't have that, let's set it back to 0 so it loops around. If you're just in the range, it goes immediately to this node setup. Anyway, where it gets the added version of this and sets the current goal to that, so being 1 further than it was last time around. And then passes that to the blackboard, because that, again, is the thing that drives all the behavior here. So if we go to the not random walking, but path enemy is what I called it, this blackboard, it's very, very simple. What it does is, in this selector, it checks, is random order set, yes or no? If it is, it goes move to current goal. Once it reaches that current goal, it goes pick random array, which is literally just casting to the AI path enemy to call that event, and it picks a new random location to move to, and then it does the entire thing again. We could even have triggers within the world to switch it between sequentially and randomly going through these, because this behavior tree will just run the other way if we do that. I don't really see a reason to do that right now, but it would be a very, very easy feature to add, because, again, if it is not set to being random, that means it will just... That's definitely the wrong behavior tree. If it's... where is it? Here. If it's not set to being random, it just moves to the current goal and then picks the next goal, which is the exact same thing, but it just calls the pick next goal event from that blueprint. And that's how this works. So, yes, this is fun for enemies. It's also useful for just NPCs and stuff, right? So this is going to be a behavior tree I'm going to be using a lot, I assume. And again, there is a potentiality for during runtime switching between random and sequential. We're almost there. We are almost there. Next up, we have this one over here. And we've already seen a little bit of that. So this, again, all stuff that all usual enemies have. It's just hitbox. It's just the save point system. We have 2 keys here and a variable that got added to this one. And that is the starting location and whether or not the player is in radius. That gets set to 0 or to false by default, because otherwise it bugs out a little. Because the behavior tree or the blackboard needs a value assigned to it for some reason. Otherwise it assumes for a tick or two that it does have a value, but it doesn't. It's kind of weird. Anyway, so the real magic here happens in the behavior tree, because as you can see, everything that happens here is event tick. It just sets the collision sphere, which is this thing over here, which has the particle system parented to it. So it will scale together. So if I scale this down, the particle system should scale with it, but it doesn't. It does in world. That's due to probably something to do with this construction script. That's not what we're talking about today. Very similar to the other AI we had. When we go into the collision sphere, it sets player on radius to true, passes that onto the blackboard. Once it leaves, it does the exact same thing, but sets it to false instead. And then we go into the actual behavior tree of the chase enemy radius. It is the most nodes I have in a behavior tree, I think. This one took me a while to figure out and to get working properly. And this is actually a lot simpler than some of the previous versions of this behavior tree that I've made. So sometimes simplicity works, because the simpler your system is, the less points of failure there are. So what happens here? We have a check whether or not player is in radius. If that is not the case, move to start location. If you're already at start location, there's nothing much to do. But that means that if I move out of the radius for any reason whatsoever, it just immediately starts moving back to its starting location. Because otherwise, if I don't do that and I leave the radius once it started moving, it will not move back. But if it is set to being true, so I am inside of its radius, it starts the look at player task, which is the exact same task that I've used in the other AI that we've already taken a look at. Then it gets the player location, which is as simple as just get player character, actor location X, Y, and get actor location Z. I don't know why that is different. Oh, that's different for the same reason that I had the line tracer before. It gets the X and Y value of the player and it gets the Z value, so the height value, of the actor itself. I really should just do a line tracer here as well. I don't know why I didn't. I might change that around to just do a line tracer, because now it wouldn't be able to walk up slopes, which would be kind of stupid. I don't know why I did it in a stupid way. And then it just passes that to a blackboard key as the player location. It's really that simple. Then it moves to that player location, which is as simple as just getting that blackboard key, AI move to. Whether it succeeds or fails, it goes on to execute. Sometimes it wants to fail. I don't exactly know why. Also, hold the fuck on, because I think get player location. That's get random reachable point and radius. Okay, never mind. I thought I had to move to twice for some reason, and that would be not bad, but kind of unnecessary. Then it waits for 1 second with a random deviation of 0.6 seconds, and then moves back to its starting location. So, not too complicated altogether. Was a lot of bugginess trying to work this out. This was also one of the first ones that I actually made an AI for, right? So, this little dude over here taught me so much, and honestly, making this guy is what made me feel comfortable with behavior trees and AI in general in Unreal. Because all these others I've made pretty easily. This one took me a while, mostly because I was just learning how to think with behavior trees. And I'll just show you this one real quick. I don't think this one even has a behavior tree. Never mind, it certainly does. So it's got 2 keys. It's got a movement radius and a wait time, again, just as the shooting enemy does. And when we go to random walking, it doesn't have a behavior tree after all. Hold on. AI controller, roam. It does have a behavior tree. It's just stored in a weird location. Okay. All it does is move to a random location, which it gets through very much known ways, right? Get the actor location, get a random point within navigable radius. The navigable radius is something that we put in through that variable. Then it moves to there. Whether it succeeds or fails, it moves on. And then it waits for a custom amount of time wherever it is. There we go. It waits for the custom amount of time again, and then it repeats over and over and over again until it dies. That's about 30 minutes of explaining my artificial intelligence enemies to you all. I hope that I was somewhat cohesive. I didn't really plan this out too well. I looked through all of the behavior trees and stuff like that to refresh my memory before starting to record this. But by no means is this any kind of proper tutorial. It's more of just an overview of this is how I did this is how I made it work. So it's by no means meant to be something that you can follow step by step. It's more of if you already have a general understanding of Unreal and of programming in blueprints and behavior trees, this is how it works. Maybe it can give you an idea or two. Maybe it won't. If you are not yet familiar with this, you're probably not watching anymore, but holy damn, this will be a bad tutorial. Now, I will be doing a little bit of experimentation with the Devlog format because I will not be uploading devlogs every single week, simply due to the fact that progression is relatively slow. I've got a lot of other stuff going on in my life, and that ends up with not a lot of progress every week. Every 2 or 3 weeks, there will probably be a decent amount of progress to show. And some of those weeks will be filled by things like animation live streams and stuff like that. Some of those will be filled by videos like the top 5 level design principles or whatever I called it. Videos like that, which are more like general advice and countdown videos mostly, because anything with a number in the title, like top X, just fucking print money. This channel isn't monetized, but just as a figure of speech. And I might do a tutorial or two here or there. But what I will also probably start doing again is recording my development as I'm developing, rather than doing these recap style videos. So what I will be doing is, when I'm developing, I will be recording. You'll get my live reactions to things like figuring out how things work, if things work, my live reactions to things bugging out, that kind of stuff, and I will compile that within a devlog. And then when I feel like I have enough material for a long enough video, so if I've got like 15 to 20 minutes of proper devlog, then that will go up. So maybe that will be the material from a week, maybe that'll be material from 3 weeks. That is how I'm going to try to change up the devlog format a little bit and add some other types of content to the channel as well. Some of which might be actual tutorials. I don't know if I would consider myself to be knowledgeable enough to be making tutorials, but I can probably like do more in-depth and more step-by-step recreations of like the things that I've made, right? Something like this. I don't know how I would like market this as a tutorial, like make a wandering enemy or something like that. It's a very specific type of deal. But something like this, make a chasing enemy, for instance. I could make a tutorial step by step on, and it's pretty easy to recreate. So I might do some of those to fill up some gaps in content, frankly, but also because I feel like those are a little bit more likely to get found by other people. So a couple more fun videos. I will also maybe be doing more videos like the I made a VR game in a day video. Like the other project that I have in mind when I get the time is a tower defense game. So I might make something like, I made a tower defense game in a week. I don't know if I'll be able to finish that within a week, because I plan to like have a level editor and stuff like that as well. And that might be formatted more like the other type of new devlog that I want to be doing. But it will not be fit in with like this playlist, right? Anyway, that's been the devlog for this week. I need to get to editing. Well, not really editing, but just like cutting the front and end of the video from this. And that's the stop recording button. I don't want to start playing. So yeah, all that. Subscribe and stuff.